Algebra 1, Lesson 30, we are looking at graphing functions. Our goal is to be able to make graphs and decide if they are functions by looking at them. So a couple things, a couple vocab terms to remember. Linear equation, we are talking about an equation whose graph is one line. Linear function, a function whose graph is one line. Now these sound almost exactly the same, but we do have some exceptions. Not all equations are functions. Okay, I'm thinking about things like our vertical lines. Vertical lines are not functions. Now we can graph our linear equations in a couple ways. One is graphing sets of ordered pairs and connecting them. Whereas the second one, we are taking the information given in the equation to be able to graph it. So things like if we're in slope-intercept form, being able to say what's the slope, what's the y-intercept, and graph it from that. So if we take our equation and we want to know a table of values, we would say, okay, I have 9x minus 3y equals negative 3. I want to get y alone. Really, I'm putting it in function form so that I can say, all right, if I input different values for x, what do I get for y? So first, I need to put this into function notation, which means I need to get y alone. So let's do that. And the first thing we need to do is get rid of this 9x. Okay, that's not going to be helpful. So I need to subtract 9x on each side because I want to get it away from that negative 3y. Okay, so I have negative 3y equals negative 9x minus 3, and I divide by 3, negative 3 on each side. Now this is one where I do want to divide it out. So I say, all right, negative 9x divided by negative 3 is a positive 3x. Negative 3 divided by negative 3 is plus 1. So we have our equation y equals 3x plus 1, which means when we get to a table, y equals 3x plus 1, and I want to fill in this information, I can just say, all right, let's input our information for x. So we would say, all right, if x is 1, then y, there we go, y equals 3 times 1 plus 1. So y equals 3 plus 1, that's 4. So my box right here is going to be 4. And I would say, all right, x is 1, y is 4. So I'm right here. And then I'm going to do that same thing for 2. Y equals 3 times 2 plus 1. And that gives me 6 plus 1 is 7. I do it for 3. 3 times 3 is 9 plus 1, that's 10. So I plot my other values, 2, 7, and 3, 10, there we go. And I check to make sure that I'm correct. All right, so let's look. I should have, there it is. I should have my points lining up right there, and I do. Okay, so we've made a table of values and plotted those coordinate points, and that gives me my answer. Okay, so graph each equation. You can check it on a graphing calculator if you would like, and we need to decide whether it represents a function or not, and whether it's linear or nonlinear. So our first one is y equals x, other one is y equals x squared. So we would say, okay, if we have all of these different values for x, what is y? Well, in this first one I'm saying, okay, if x is 0, well, y is 0. If x is 1, y is 1. X is 2, y is 1, or x is 2, y is 2, and so on. In this other one, we still plug in our values for x squared, okay, and we would say, okay, y equals negative 2 squared. Well, negative 2 times negative 2 is a positive 4. And then we do it for negative 1. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. So we have our values. And when we go to graph them, we should see something like this. We have a line and a non-linear graph. So this one's linear, this one is non-linear. The question though is, do we have a function for each of these? One way that we can check is our table of values. Does every input have one and only one output? And we would say yes, it works for A. We can also check by the vertical line. Okay, by checking using a vertical line, and we can say, all right, if I use this vertical line, does it cross in just one place? Yes, it does. And we check another place, does it cross in one place? Yes, it does. All the way we could say, yes, it just crosses in one place. This is a function. And then we check our second one. This is nonlinear, but it doesn't mean that it's not a function. based on our table of values, yes, every input, every x value has one and only one output, y value. So it works based on the table. Now the question is, does my vertical line work? We would say yes, it crosses in only one place in all of these areas. Even though it looks like it goes vertical, it doesn't. It keeps going out, keeps getting wider and higher. So this is also a function. Let's try another one. All right, use our table of values to graph the function. Now I'm going to go back and say, all right, since this is not in function form, I am going to get y alone and work from there. Okay, so if I want y alone, that means I need to subtract 2 from each side. Let me get white, hopefully. Okay, so I need to subtract 2. No, it doesn't want to work for me. There we go. You can see that. Subtract 2 from each side, so I have y is equal 3x minus 2. So I don't have x values yet, but let's choose some. Let's say, what happens if x is negative 2, or 0, or 3, or 4, or 6? Okay, let's figure that out. So we would say, all right, let's plug it in, and y equals 3 times negative 2 minus 2. All right, so y equals negative 6 minus 2, so that would be a negative 8. So I would say, all right, my plot is going to be at negative 2, comma, 8. So it would be down here. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Yep. All right, negative 2, comma, 8. 0, we plug it in and we get a negative 2. All right, so my y-intercept is at negative 2. Plug in 3 and we get 9 minus 2 is 7. So we're at 3, 7. Okay, and we could keep going on. 4 would be at 10. And 6 would be all the way up at 16, which I don't have a big enough graph for. But we can see that we have these order pairs that make our line. So get it into function form and then choose some x values that you can plot. It makes sense, though, to choose them that are pretty close to our origin so that we don't have to graph things like x equals 100. Okay, this is another one you can try. Remember, get y alone. Get y alone. All right, another one to try. Get y alone and then plug in some numbers. Now let's use our logic to figure out, we have these equations, which graphs do they go to? So we have graph 1, 2, and 3. Let's say, all right, I want to look at y equals x plus 3. Which graph does that go to? Well, let's pick a value on each of these graphs and say, let's plug it into that equation and see if it works. Like, let's say x is 8 on here. It looks like 8 goes to 6, about 6. Well, does that work with our first equation, y equals 8 plus 3? No, we should have a y being 11. So graph 1 doesn't work for my y equals x plus 3. We try it again, okay? Let's pick, I don't know, 0 for graph 2. We should say, all right, y equals 0 plus 3. So y should be 3. And it looks like, yeah, actually, y is 3. And let's just check graph 3 just to make sure that wouldn't work as well. Let's plug in x as 2. It looks like it should come out as about 5. So we would say, all right, y equals 2 plus 3. So y should be 5. Okay, that one actually works. So let's try another point on each of these. Let's try negative 2 for this graph number 3. So we would say y equals negative 2 plus 3. Well, that should be 1, but it comes out at 5 again. So I would say no. Graph 2 works for x equals, y equals x plus 3. So this is y equals x plus 3, which makes sense since y equals x plus 3 is a linear graph. Okay, let's figure out these other two. Let's try some other points. So y equals the absolute value of x plus 3. Let's try a point at, let's try 8 again. That's fine. So y equals the absolute value of 8 plus 3. So that should, again, be y equaling 11. But y does not equal 11, so that's not going to work. So let's check graph number 3. Okay, if we do graph number 3, then we are saying, all right, let's check 2 again, and y equals the absolute value of 2 plus 3 gets us 5, so that works. How about that negative 2? Because it didn't work last time, so we do the absolute value of negative 2 plus 3. That gives us 5. So graph 3 is y equals the absolute value of x plus 3. That V shape that you see there is going to work with those absolute value functions. That's a pretty typical one. And then let's just check with y equals the square root of x plus 3. Let's pick a number, how about 4? So we would say y equals the square root of 4 plus 3. So I should come out with y equaling 2 plus 3, which is 5. Does it stop at 5? Yes, it does. Okay, so this one is my y equals the square root of x plus 3. Okay, so we can plug in numbers to see what do we have. What do we have? All right. Use the graphs to identify the domain and range. Well, remember, domain is something that we've talked about, and it is the possible x values that we have. Well, if we're looking at A, then we're saying, okay, my x values that I can have. It looks like I'm starting at 0, so x is going from 0 to, well, that arrow tells me that it goes on to infinity. So I would say that x needs to be greater than 0 but less than infinity. Okay? Can we include 0? Yes, because it's a filled in dot. So x needs to be greater than or equal to 0 and less than infinity. And we can show that as a combined inequality. So that's my domain. What about my range? We're talking about my y values. Well, it looks like because this goes into infinity, my y's will go to infinity as well. But where does it start? And it looks like my y's start at 1. We need to be greater than 1. Can we include 1? Yes. So we would say 1 is less than or equal to y is less than infinity. Y is going between 1 and infinity. Now we look at my parabola here. We say, okay, what are my domain values? Well, if we were only looking at the graph, it looks like it stops at negative 4 and 4. But because there are arrows on the ends here, it goes on forever. And it gets wider and wider and wider. It actually goes from negative infinity for x to infinity. Okay? This goes on forever. Now, if we were looking at the range, it looks like it starts, my lowest point is at negative 2. So negative 2 we include because it is a value on the graph. So negative 2 is less than or equal to y, which is less than infinity. It goes on for the ranges forever and ever and ever. Okay? So, the other way that you can show this is the domain is greater than 0, that's what we talked about here, and the range y is greater than or equal to 1. The domain is all real numbers, which is what we said right here with the going from negative infinity to infinity, and the y is greater than or equal to 2, which is what we said here. These are more formal ways of writing them, something that you will be expected to know and use in high school, so that's why I introduce them now. Last one on this video. The soccer team raises money by washing cars. They charge $5 per car and spend a total of $4 on soap. The table shows the amount of money they raise. Make a graph and use it to find the amount they raise by washing 7 cars. Write the rule in function notation and use it to check the answer. So, what we would say is, if they charge $5 a car, that means that they're getting $5 a car, but they already spent $4 on soap. So we would have to say something like f of x, okay, our function on x is 5x, so $5 per car minus that $4 we spent on soap. And we can see our table of values there and how that works with if we have 1 car all the way up to 5 cars. Okay, so you can see our function and our linear equation here that we can plug in our different values and plot on our graph. Okay, so if we want 7 cars, that means that we are going to go to x equals 7, go up to right there, and see that it's going to be about $31 for 7 cars. We're going to earn $31. Well, I hope this was helpful for homework and for studying.